Hello students, I am Ankita, I am a science teacher. So today we will be discussing about the fourth chapter from 10th science part 1, which is effects on electric current. Okay, so today the topic of discussion is Fleming's hand rules. There are two basic Fleming's hand rules, which is Fleming's left hand rule and Fleming's right hand rule. So let's see, moving on to the next, that is Fleming's left hand rule. Right, you can see in this particular diagram that two magnets are placed in a certain distance, and one conductor is there which is in between. Right, two magnets are there, that means magnetic field must be there, and this conductor which is coming under this magnetic field. Right, once it comes under the magnetic field produces force on it. Right, and this force is direction of this force we can easily find out with the help of Fleming's left hand rule. How? Let's start. Let's just stretch your fingers of left hand, thumb, index finger and middle finger. What it indicates? This index finger direction. This index finger indicates direction of magnetic field. This middle finger indicates direction of current, and the third parameter which we are actually interested in finding out, which is direction of force. This way the direction of force is applied. So in the similar setup which you can see in this particular figure, if you set up your fingers accordingly, you will definitely get the force, direction of force, which is the direction of thumb. In this particular diagram, direction of force is upwards. Okay, so this is how the Fleming's left hand rule indicate. You can easily explain the Fleming's left hand rule with the help of these certain parameters. Okay, so basic application of is electric motor for this Fleming's left hand rule. The electric motor works the same way as we have already explained. The magnets, the conductor is coming in between in the field of magnetic in the region of magnetic field, and because of that it applies force on the conductor. Right, moving on to the next part, we'll be discussing about electromagnetic induction. In this particular diagram you can see now the conductor which is introducing in the magnetic field is moving. Right, and this moving conductor is attached with volts to measure the voltage. Right, so as because it is moving, conductor is moving inside the magnetic field, it induces the current into it. Okay, जो कंडक्टर में करंट है वो इंड्यूस हो रहा है just because it is moving through the magnetic field. It is not stationary this time. So this Faraday's law of electromagnetic induction, whenever conductor moves inside the magnetic field, there will be induced current into it. Okay, so based on that, our next topic of discussion is Fleming's right hand rule. What it states that, again, stretch your fingers of right hand, thumb, index finger and current. Two magnets are placed in a certain distance, you can see in this particular diagram, and conductor is moving, it is not stationary, it is moving inside the magnetic field. So whatever directions are appearing, we can easily find out using the right hand rule. We are interested in finding out direction of current because we know the direction of field, we know the direction of force. Force in the way, force that means the way, the direction in which this conductor is moving. We know that conductor direction of field, that is magnetic field, we already know. So if you arrange these fingers similar to this setup which is shown in the diagram, you will definitely find out the third parameter, which is direction of current. That's it. It's very simple rule. Fleming's left hand rule में हमने क्या देखा? We have found out direction of force, and in this Fleming's right hand rule, what we have got? It is direction of current. So two things, like from these two rules you can two things just try to understand और ये समझ लो कि अगर आपको दो पैरामीटर्स पता है तो थर्ड पैरामीटर आपको इजीली समझ में आ रहा है just because of this Fleming's rule. Okay, so that's it about Fleming's right hand rule. Electric generator, which you can see in this particular diagram, like it works on the same principle of Fleming's right hand rule, which is that again magnetic field is there, conductor is inducing in between, and because of that current is induced in the conductor. So it works on the same principle. Electric generator is an application of this right hand rule. So we have seen Fleming's both rules, left hand rule and the right hand rule. So the name is given by the name of scientist, which is Fleming, John Ambrose Flemings in the late 19th century. This Fleming they have stated these two rules. That's why the name of scientist is given to to these two rules. So what it exactly contains, what we have seen so far, these three parameters which we are getting through either Fleming's left hand rule or the right hand rule, we are getting directions in these two rules. We are not actually getting magnitudes of it, but yes, definitely we are getting direction of three parameters. Which are these three parameters? The current, the force, and the magnetic field. Once you know any two parameters from these three parameters or the yes parameters, then you can easily find out the remaining one. Okay, so yes, this question you can see on the screen. Explain the following diagram and its concept. Fleming's left hand rule and the right hand rule. So this question has frequently appeared in your past board examination. So now I'm sure, like after attending this particular quick revision session, you will easily grab the mark if this question comes in your exam, right? If you like this particular revision session, then surely like, share, and subscribe. Okay. Thank you so much for attending this session. Thank you so much.